Volumes of Revolution, the Shell Method Part 2. In this video, we're going to look at a couple examples where we revolve a region about an axis and find the volume of the shape that it makes using the shell method. Recall from the first video that the volume of the cylindrical shells that we make, if we add them all together, is the integral from A to B of 2 pi r times f of x dx, where r was x. Now this will change for the second example, but for now we will use this. So let's revolve this about the y-axis. I'm going to draw a representative cross-section with width dx. And if we revolve this rectangle about the y-axis, it will arc out a cylinder, or really the outer layer of a cylinder, with a tiny width of dx. So I know that the volume will be the integral from 0 to 1, because those are the limits that I've chosen. I know that the radius of this cylinder is going to be x. And then the height of the cylindrical shell will be the function height, e to the negative x squared, and then dx gives it the third dimension. Let's do the antiderivative here. I'm going to pull the pi outside. You'll see why the pi only in a minute. From 0 to 1 of 2x e to the negative x squared dx. The proper technique for integration is integration by substitution, which I usually call u sub, where I will let u equal negative x squared. The reason why is because I see if I take du, I get negative 2x dx, and I have almost all of my du. The only thing I'm missing is the negative sign, so I'll multiply by negative 1 on the inside and on the outside. Then I will rewrite the integral. Negative pi times, now e to the negative x squared becomes e to the u. Negative 2x times dx is exactly du. But don't forget to change your limits, because the original integral, we're going from x equals 0 to x equals 1. So now I need to go from u equals to u equals. So if x equals 0, well, that's still 0. But when x equals 1, u is negative 1. And then we can find the antiderivative. Well, the antiderivative of e to the u is simply e to the u. And then we can plug in our top limit, minus and plug in our lower limit. And if I were to rearrange and make things a little bit prettier, I would end up with pi times 1 minus 1 over e. Just to see what I did, I distributed the negative sign here inside and flipped the order of things. So let's take a look at another example, but we will change it up a bit here. So the region we have in question is going to be bounded above by y equals x plus 2, below by y equals 2, and on the right by x equals 3. And we want to revolve this one about the x-axis. And we're going to use cylindrical shells. Now, there might be other ways to do it, but I want to do this example using cylindrical shells. So I will draw a representative shell. Notice if I'm going this way, my rectangle will be drawn as such, and it'll have a tiny width of dy. The radius will be this length from the axis up to the function height here. But notice this will not be x, it'll be y. Furthermore, the length here, or the height as I called it, of the rectangle is not the function height, either y equals x plus 2 or x equals y minus 2. Neither of those is correct, because the length is always big, I'll call it L, minus small over here. So 3, that is the big X, x equals 3, minus the small x, y minus 2. And if I simplify this one, I end up with 5 minus y. So now the volume of one of these cylindrical shells is going to be length times height, if you would, 2 pi y, times the tiny width of dy. And if I want to find the entire volume, we will add all of these cylindrical shells together. Now I'm going to rewrite this a little bit to make it prettier. So I'm going to pull the 2y to the front. Then I'm going to distribute this y back here. And then I need my limits. Well, my lower limit, I start making these cylindrical shells right at y equals 2. And I'm going to stop making them up here, right about there, when x equals 3 or y equals 5. Then we can do the antiderivatives. I'll pull that 2 pi outside and integrate. From 2 to 5. Leave the 2 pi out. And then I'll plug in the top limit, so I'll have 5 times 5 squared. So let's see, that's really 5 cubed over 2 minus, plug in the lower limit. Oops, let's plug in the top limit over here. I still got one more of those to do. Now we'll plug in the lower limit, and I'll put it down here just so I can see it a little bit better. Minus 5 times 2 squared. Yes, I realize we could simplify these things. Sometimes I do, sometimes I don't. And then 2 cubed over 3. And I'll put those in parentheses to show that that was the top limit. And then simplify that as desired.